All right, so far in the videos, we've seen how to integrate if we had a minus infinity as one of the bounds. We've seen an example where we had plus infinity as one of the bounds. Now I want to do something slightly different. Let's see what we get. Example 7.1.3, I want to find the area of the region between y equals 0 and y equals 1 over 1 plus x squared. Give a sketch of your region. All right, so let's start like we would any area question, except that something is fishy because we're in proper integrals. But let's see, so intersection point. All right, my two curves are y equals 0 and 1 over 1 plus x squared. If I multiply both sides by 1 plus x squared, I get 0 equals 1. All right, so I have no intersection points. All right, let's try to find top versus bottom. So they never intersect, and they're always continuous. So at some point, let's pick x equals 0. So at x equals 0, the first curve is at 0. The second curve is at 1 over 1 plus 0 squared. It's at 1. So that means this curve will be on top, and this curve will be underneath for every single value of x. All right, so I start at 1. I sort of know what the curve look like. It goes down a bit and goes towards 0. So this is the region we're looking for. Oops. All right, so let's say this is good enough. That means the area is top minus bottom A to B. I don't have an ending to any of this, so I'm going to get infinity, minus infinity to plus infinity. We said the top was y equals 1 over 1 plus x squared, so that's what I'll put in first, and then bottom is 0. All right, that means we need to integrate an improper integral that has both bounds infinite. All right, so that's what I said when I said I want to do something slightly different. We'd seen these two cases, but we haven't seen that one yet. All right, so I need to pick an A, any A would do, and I need to split it into two parts. So no need to be original here. Let's take A equals 0. So I need to consider the integral from minus infinity to 0 of 1 over 1 plus x squared. I need to evaluate this. If I get a finite number, I will need to look at the second half separately. All right, so this is a limit as t goes to minus infinity, t to 0, 1 over 1 plus x squared dx. All right, at least there's an easy integral. It's just the arctan. And so I get the limit as t goes to minus infinity, arctan of 0 minus arctan of t. And so that's 0 minus arctan of minus infinity. That's one of the limits that we saw in that first chapter. That's minus pi on 2. All right, so let me bring this down just to say this integral converges. All right, so as long as you get a finite number, you keep going. We get the integral from 0 to positive infinity. That's going to be the limit as t goes to positive infinity, 0 to t, 1 plus 1 over x squared. Again, that integral is pretty straightforward. Arctan of x is 0 to t, limit as t goes to positive infinity, arctan of t minus arctan of 0. That's arctan of positive infinity, arctan of 0, 0. And so arctan of positive infinity, if you don't remember, you could look back at chapter 1, but really, just to refresh your memory, those two limits we're computing corresponds to the horizontal asymptote of arctan. And so here I'm getting pi on 2. And so the area, which we said was the integral from minus infinity to plus infinity, also converges. And we'll say that it's equal to the integral from minus infinity to 0, and then 0 to plus infinity. And we just computed both, and so we just add them. And we get pi. All right, so this area here is pi. Right, so it goes off to infinity, but the height is so tiny that even if you add up all of these little pieces, you still get something finite.